Hi class. This video we're going to go into a new topic, 3D particle systems. So under week 9, I thought this might be a fun project to do for a week. We're just going to create a particle system in 3D. So we're going to combine the 3D graphics stuff that we did last week with the class-based programming that we did a couple weeks ago. So I'm just going to create, in the video I'll create the particle system. I'll kind of go over how it works. And then I'll add in my composition of the cat into the particle system just as an example. So basically you guys can either add your 3D composition into the particle system, or you can create a new composition for your particles. So there's a lot of different things that you can create to make different variations in the particle system once you have it working. So I'll go over that and then I'll do a quick example, and then you guys can kind of go from there. So I'm gonna open up GitHub just to get started and go to my MMP 310 repo, and I'm gonna open this up in Sublime. And so last week we made the 3D graphics and we did the 3D cat as well. So I have a couple links there. And this week we're going to make our particle system. So I'm going to start, I'll just add a link here, a list item, then an anchor tag, and we'll call this particle system. And I'll put the link text there. So I'll save that, and then we'll create this folder. So go back to GitHub and just go to repository, show in Finder. And so here's the MMP 310, and I'm going to use my cat as a starting point, but I'll probably delete a lot of that code as we work through it. So I'm just going to duplicate this and call this 3D particles. Or wait, no, I called the link particle system. Well, I'll use 3D just so they're in the same place. So I'll see 3D particles instead. So that'll be the name of my folder. And then I'll go to Tools, Sublime Server, Start Sublime Server. And so now I can go over to localhost 8080, go to MMP 310, click on particle system. So we kind of have our cat right now, but we're going to do some updates and make a little particle system. So I'm just going to open this up over here and increase this a bit. And so before we get into our code, let's just look at what a particle system is. So my example is going to be based on one of the P5 examples from Simulate particle system. And so you can see this is a really simple particle system where basically you have a bunch of circles which represent different particles, and those are having various speed and velocity applied to them. And so you get this kind of like raindrop or water fountain effect. And so particle systems are used for pretty much any time you see any graphics in a video game or a movie. Whether it's fire or smoke or anything that has a lot of elements to it, that's going to be a particle system. So let's see if there's a couple other examples of particle systems. Here's one where we're just adding multiple particle systems. Let's see. Here's a smoke example. So this kind of looks like smoke, and you can use the wind to blow the smoke in different directions. And so this looks a little bit more like, a realistic thing, but it's basically using almost exactly the same code as the previous examples, just with a slightly different output for the display. So it's really useful for visual effects. This snowflake is a particle system. So particle systems can be used for virtually any effect, whether it's rain, snow, fire, smoke, all those different types of things will use a particle system, explosions, things like that. So a particle system is a bit complicated because we're dealing with all these different particles. And so we need two classes to kind of make it work. So we're going to start by making a couple classes and just making a simple particle system. and then making sure it works in 3D. And then we'll kind of work from there. So I'm going to close my home page and go to 3D particles and open up index.html. I'll rename this 3D particles. And then I'll open up sketch.js. So I've got a lot of stuff in here that I don't really need for this example. So I'm just going to go ahead and delete all this and start from scratch. So I may go back to this sketch in my cat folder to look at some of the cat graphics later, but for now, we're just going to start things off simply. So I'm going to delete everything so we just have a clean sketch.js and start with a comment as usual. So I'll say this is the 3D particle system and just put the date for today. And so to get started, our global variables are really simple for this sketch. We're just going to have a reference to our particle system. And that needs to be global because we're going to be doing some stuff in setup, but then we're also going to use it in draw as well. So I'm just going to say let particle system. And I got it. Particle is kind of hard to spell, so make sure you spell that right. You may also just abbreviate that if you want to make it easier. You could call it like P system or something like that, because I misspell. It's sort of like circle. It's really easy to misspell. So then we're going to do function setup as usual and create canvas as usual. And so we're going to do window width, window height, to take up the full browser window. And then again, since we're working in 3D, I'd have to put this last argument, webgl, here. And then I'm just going to instantiate our particle system. And the particle system is going to take a one argument, which is the position where we want it to start. So we're going to make our particle system, this is going to be a class, which we'll create in a second. So we're going to create a new system. And we're just going to give it a vector. And so this is a new concept. So I'll go over what that means really quickly. And the way that we're going to do that, so I'll look in P5 in the reference. This is a vector, so I'm just going to search reference. So we're going to use create vector. And what create vector does is it just kind of gives us a new point with an X, Y, and Z coordinate. And the reason we're doing that is to simplify our math a little bit. So you may remember in some of our other examples, let's actually go back to an earlier example real quick. So if I go to my website and look at some of the old examples, we made this class example where we had the clouds and the fish and they're animating. And so if we look at the code for those clouds and fish, you guys should remember this. Here's cloud.js. We have this update function where we're animating the cloud by saying this.x plus equals 2. That's what's making these clouds move across the screen 2 pixels at a time. And so that's good if we're just working with one axis, the x-axis. But when we're working in 3D, we have to keep track of all 3 axes, x, y, and z at the same time. And so a vector is basically just a simple way of keeping track of 3 different points, x, y, and z. So when we create a vector, essentially what we're doing is we're just creating a point in space that has an x, a y, and a z value. And that's just the point where we're going to start our particle system. So our system is going to take one variable, which is the create vector function. And then that function takes 3 arguments. The x will do 0, y 0, and z 0. So we'll just start right in the middle of our 3D environment and just design it from there. So that's our particle system. We'll come back to this. Once we finish the setup, we'll make our system. So for function draw, so let's just set a background. I'm going to make it kind of dark again so we can see our particles. And then last time I used these like scene controls, I wanted to kind of go over how to make some those controls, so to also explain the rotation and movement on the X, Y, and Z axis. But an easier way of doing that is just using the P5 function orbit control. So if we look at orbit control, that basically is just like some built-in controls where we can zoom in and out of a scene. So you can see, it's kind of small, but you can see the example here. If I click and drag, I can rotate this object. And then if I scroll in and out on the mouse, I can zoom in and out. So we can get all that just from one function, orbit control. So rather than building our controls, for this simple example, I'm just going to use orbit control here. So I'm just going to write orbit control at the top, and that's going to take care of the rotation for us. So for the rest of the scene, I'm just going to put a simple light. I'll put a little comment here just as a reminder. So drag to rotate up and down, and scroll to zoom in and out. So that's our orbit control. I'm just going to put a light in the scene. So I'm going to say directional light. And I'll make it pretty bright. So I'll say like maybe 220 and maybe a little blue. Just to add a little bit of character to the light. So I'll put a little more blue than red and green. So we have 220 red, 220 green, 255 blue. We can always change that later. And then I'm just going to put the same values that I had in my cat sketch. So the direction is 1 on the x-axis, meaning that it's pointing to the right, and 1 on the y-axis, meaning that it's pointing down, and then -1 on the z-axis, meaning that it's pointing away from the camera. So away from our sort of position as the viewer. So that's just kind of a basic directional light we'll use. I might come back to that if we want to go over that more. And then we're going to just add a couple things with our particle system. So we'll say particle system, and this is in our draw loop. So this is going to be constantly happening as our particle system exists. So we're going to add a particle for every frame of the draw loop. So just like with rain or snow, there's always new elements getting added into the system. So we're just going to add one element every draw loop. So we'll be getting new particles. And then we're just going to update this particle system. So we're just going to say particle system.update. And that is just going to do the updates that we'll go over in the class. So that's basically everything I need for my sketch.js script. If you guys want to add in some more lights or other things, you could do that here. But for now, this is all we really need. I'm just going to throw a box in here just so we can get some orientation in the screen. So I'm just going to put a box at 100 and throw that in here so we can see that. And I have a, whoops, that should be a semicolon. Oh, and I'm getting system is not defined. So let's just comment this out real quick just so we can see what that looks like. Okay, so here's our scene with just the orbit control. So you can zoom in and zoom out. Be careful, if you zoom too far in, your camera goes past the box and then you can't see anything. So just zoom back out. So there's our box, and you can kind of see our lighting because with the box, we just have these flat surfaces, so the lighting is evenly distributed. So you can see 3 sides of the box are light and 3 sides are dark. If we change this into something with smoother surfaces, like a torus, then you'll be able to see a bit more of the lighting. Okay, and let's turn off the stroke. So I'm just gonna say no stroke up here. Okay, so now you can kind of see the lighting that we've got going on. It's slightly blue, but it's mostly pretty white. And we can see the sort of light sides and the dark sides of the torus. And again, we can zoom in and out. So that's our basic scene setup. I'm gonna make this background even darker just so we can really see the geometry. Maybe I'll do like 20. Okay, that's pretty good. So I'm going to take this torus out, and then let's build our particle system. So I'll uncomment these guys. And so the system itself is very simple. The particles are what actually do most of the work. So I'm going to go back to index.html, and we're going to be adding a couple new scripts. So remember, when we add classes, to our projects, we have to remember to add the script files in the HTML so that the new script files get loaded. So we're going to start with our system. So I'm going to do script source get system.js. And remember, this is capitalized because the system is a class. And the way in code that we signify something as a class rather than a variable or a function is with a capital letter. And so I'm going to name the file with a capital letter as well, just to make that consistent. So I'm going to make a new file and save this as system.js. And I'm using a capital S here just to match the HTML. But if you do lowercase letters, it'll still work as long as it's the same. So we're going to start our class. So we'll say class system. And it's very simple. So we're going to start with our constructor. And so remember, our constructor gets this vector. Okay, so the vector is the X, Y, and Z points. So we're just going to call that a position. And so a vector is just like a position in space. So that position, so we're going to set an origin for our system. So that's where new particles will appear. So we'll say this.origin. And we're going to say position.copy. So without going too far into this has to do with the way that JavaScript works, where we need to make a copy of that position so that we don't change the original position, because then everything would be updated at the same time, which is not what we want. So whenever we make a new particle, we're going to copy that original position. Next, we're just going to add a list of particles. So I'm going to say this.particles equals empty array. So that's an empty list, which we're going to add particles to later. So that's our constructor. That takes care of everything that happens right here. So the next two parts of our particle system are the add and the update. So we need to add particles and update particles. So my next function inside of my class is add. And we're just going to create a new particle and push it onto our list. So I'm going to say this.particles.push new particle. So we haven't made our particle class yet, but we'll do that next. And so we're just going to create a new particle. We're going to create it at this.origin. Okay, so remember, this.origin is that position that we get from our sketch. So that is right here. So it's going to start at 0, 0, 0. If we want to change that later, we can. And every particle is going to start at that origin. And you can start to see why it's useful to use a vector here. So instead of saying X is 0, Y is 0, Z is 0, I just say 0, 0, 0 here. And then I can just call that the origin and then pass that here. So I don't have to write X, Y, and Z over and over again. So that's our entire add function. That's really easy. You guys won't really have to change anything here. You could like make some randomness in terms of this origin position, but that's not really necessary. So you guys really aren't going to have to edit the system code at all. Most of what you'll be doing is in the particle class, which we'll do next. So we can add particles, and now we can update some particles. So this is where most of the work happens. We're going to loop over all of these particles, and then we're going to display them and update them. And then we're also going to check to make sure that they're still alive, because we can't have like an infinite number of particles. That would eventually kind of hurt our computer. So we're going to make particles last for a certain amount of time and then die off. And we'll look at a bunch of different ways to kind of animate that to look kind of cool. So we just need to loop over our list, and we're going to use a for loop for that. So remember, with our for loop, we start with for and let I. And normally we start here with 0, but for our particles, we're actually going to count from the beginning, from the end of the array backwards. And the reason we're going to do that is because we're going to be removing particles from the array. And if we change the length of the array as we're removing particles, we can get in trouble where we're going to have like the wrong particles in the wrong place. And the way that we make sure that we don't do that is by counting from the end of the array backwards. So I'm going to say I equals this dot particles dot length minus 1. And the minus 1 is just because if you remember with an array, if I have an array like variable a equals 0, 1, 2, the a at 2 is going to be the last part of that array. So with our array, there's 3 values in the array, but 0, we start counting at 0. So we have 0, 1, and then 2. And so for our particles, we're going to be counting backwards. So we want to start at 2, which is actually length 3 minus 1. So we're going to say this.particles.length minus 1 to start at the last element in the array. And we're going to keep counting as long as I is greater than or equal to 0. So we're going to count through every single particle all the way down to 0. So the last element is always going to be 0. And then we're going to say I minus minus. So we're counting down 1 by 1 by 1. So we could start at 2. That's length 3 minus 1. So we start at 2 minus minus to 1 minus minus to 0. So we're just going to count backwards through all of our particles. So then we are going to say this dot particles at I, and we're going to update it first. So when we update our particle, we're going to be changing the speed, adding forces, moving the particle in space. And so then after we update it, we say this dot particles at I dot display. So we're going to draw the particle on the screen. And finally, we want to check if the particle is still alive. If it's not, then we're going to remove it. So we'll write this code in a minute. We're going to say if this dot particles at I dot isDead. So that's a function we'll create inside the particle to check if it's still alive. If the particle is dead, then we're going to remove it. And the way that we can do that is say this dot particles dot splice I at 1. So I is the number in the list where we are. If that particle is dead, we're just going to splice that one. And we're just going to use 1 because when you splice, you're splicing a part of the array, but we only want to splice one element from the array. So we're going to splice one element at I. And so that is our entire particle system. So it's really pretty simple, but with that combined with our particles is going to add a really cool effect. Okay, so let's move on to our last script, which is the particle script. So again, I want to make sure I'm adding this to the index. So I'm going to add a new script here. And this is Particle.js. And again, I'm using a capital letter because it's a class. So I'm going to save that. I'm going to create a new file and save as Particle.js. Make sure that's in the 3D particle sketch. And so this is where most of the work is going to happen, and we're going to add to this bit by bit. So we're just going to start off with the most basic version of our particle system, and then we'll move from there. So I'm going to say class particle. And so we need a constructor. So remember, when we make a new particle, we say new and then particle, and we start with the origin. So this is the point where we start. And that's going to be the position of our particle. So our constructor takes a position argument, which is the origin of the particle system. And we're just going to go ahead and assign that to the particle. So I'm going to say this dot position equals position. And so remember, that contains the x, the y, and the z value. So we don't have to worry about saving all of those at once. So then I'm just going to add a simple lifespan. So this is how long our particle lasts. So let's say this dot lifespan. And let's say we can use 255 since that's a number we use a lot. So lifespan is 255. And then we're just going to add a speed. Okay, so I'm going to say this dot speed. And that's going to be a vector as well. So instead of having x speed and y speed, since we're starting to add a lot of complexity, we have 3 different axes, the x, y, and z that we can move on. We're going to start using these vectors. So we're going to say create vector. And for now, I'm just going to leave this at 0, 0, 0. And so we'll go back here and actually do some updates. So that's our new particle. All right, so we've created the particle. Now we have to update the particle and display the particle and then decide if the particle is dead. So our update for now is going to be simple. We're going to add to this. We're going to say update here. And basically, we're just going to add the speed, and then we're going to reduce the lifespan. So we're going to say this dot position dot add this dot speed. And so using vectors is really nice because we can add all 3 components of our position, with just one function. So normally in the past, we would have had to say this dot position dot x equals or plus equals, you know, this dot x speed or something like that, and then keep going, this dot position dot y. So that's a lot of work, but vectors will do this math for us. So it's just going to take out the x of our speed vector and add it to the x of our position vector, and then continue with the y and z. So we don't really have to think too much about how that math is happening. We can just set the speed here. Then I'm going to decrease the lifespan. So that's how we're going to know if the particle's dead. So I'm just going to say this dot lifespan and then minus equals 1. Okay, so this is how quickly the particle will die. So it's going to be -1. So after 255 cycles in the draw loop, that's when our particle will finally die. So we can update this if you want the particles to have a shorter lifespan, just make this a larger number. So we can look at playing with that in a moment. So that's our update function. Next, let's do our display function. So this is what actually draws the particle graphics. And so the main thing here is that we have to push before we do anything else. So remember, with 3D graphics, we're using translations rather than X and Y positions. So the first thing we have to do is push to save the transformation of the canvas. And then we do our translations and rotations, etc. And then finally we can pop at the end. So that way we don't have to worry about having some crazy problem where we're adding translations together. So we're gonna push and pop before we do anything else. And then I'm gonna first start by translating to the position. So this one I have to write out all the positions just because of the way the translate functions work. So I'm just gonna say translate this dot position dot x, this dot position dot y, and this dot position dot z. And this is still sort of part of the template code, so everybody's code is going to look the same at this point. I'm just going to say move canvas, or let's say context, to particle position. So we're going to translate first. Later we'll add some more to this, like rotation, and then we're just going to draw our particle. For now, I'm just going to draw a box. I'm going to say box 50. And then that's actually all we need to do here. We're going to add a lot more to this in a moment. So that's our display function. And then finally, let's add our isDead function. So this just tells us whether the particle is still alive. We're going to return a value here. So remember, return from our lesson on functions. Basically, in the system, it's going to ask if this particle is dead. If it is, we're just going to remove the particle. So we need to return a true or false to say whether or not it's dead. And we can just compare the lifespan to 0. So if we're taking 1 off of the lifespan every frame. And so once we get down to 0 or lower, then we will return true. So we'll say this dot lifespan is less than 0. So if the lifespan is lower than 0, then this will be true and that particle will be removed from the system. If it's not less than 0, we'll return false and the particle stays. So I'm going to reload this code and just take a look at what we got. Nothing interesting is going to happen quite yet, but then we'll add a bit to it. So we have a box here. You can't really see anything happening because we haven't applied any forces to our box. So let's go ahead and add some speed. And so the speed is going to make the particle go in whichever direction we want it to go. So if we apply a lot of x speed, it'll go that way. If we apply y speed, well, it'll go that way. And if we apply z speed, it'll go towards us. And then if we do negative x, it'll go this way. Negative y will go this way. And negative z will go away from us. And so we can apply either just the same number for all of our particles, but that's not going to be super interesting. What will be more interesting is when we add some randomness to it. So let's look at our speed. So let's just look at x. If I just put 1 here, what you'll see is just a line. Another thing we can do is instead of just adding a speed, we can kind of give it a random range. And so that way each particle will have a different speed. So let's say random for x, random between -1 and 1. So I'm just putting this whole random function into that x component. Okay, so now I realized what my mistake was. I forgot to say position.copy. So see how there's only one particle? That's because all of the particles are referencing the same position. So what we need to do is say position.copy, and now we should see a bunch of particles. There we go. So now we see a lot of particles. It just looks like a big box. So we can make this a little bit easier to see if we change the way we're displaying that. So we'll use our kind of debugging display that we had before. So I'm going to say the stroke is green, or let's say light green, so it'll be kind of brighter. And let's say no fill. So now we'll be able to see the interior geometry of our boxes. And so now we can see there's actually a lot of boxes being created. So we can bring this lifespan back down to 1. So there's a lot of boxes, and they're going at kind of different speeds in 2 different directions. Okay, so that's kind of nice, but it's not really a particle system quite yet. So let's add some more components to it. So let's give it some random y. So we say -1 and 1. Okay, so now we're moving in the x and the y direction, and we're kind of moving outwards evenly. So with a particle system, there's usually some directionality. Like usually we're going like straight up if it's fire, or straight down if it's rain. So we can do that with our y. So let's just make this random and make this 1. So now we should see the particles are falling downwards. So they're moving on both directions on the x-axis, and they're moving downwards on the y-axis. And if we want them to fall faster, we can either make the y faster, or we can make the x less fast. So let's do 0.5 for x. Okay, so now they're falling downward faster than they're moving outwards. Okay, so we're getting a little bit of variation there. So now we need to add some z in, and to get some real volume with our particles. I'm also going to make the boxes a bit smaller because they're taking up a lot of space. So let's make the box more like 20 pixels. Okay. And let's add a value on the z. So I'm going to copy the same value for x. So 0.5, negative 0.5 to 0.5. Okay, so now we'll see we get a lot of volume, x and y, and then we're falling downwards on the y-axis. So we're starting to see more of a real particle system. That could be like some rain or some snow. If we reverse this, if we go -1, then we're going to get like more of a fire or smoke look. So that's kind of nice. So that's just 1/4, that's the speed. So let's look at other ways that we can create some variation. So we can change the size, the rotation, the position, all of this different stuff with our particles to get different effects. So I'm going to do a few examples of that, but this is kind of your basic particle system. From here, you could start to design your lighting. You could add in different colors, etc. So let's go back here. I want to add something that's going to create a nice effect for our system based on some physics before we get into more variation. And that is the concept of acceleration. So we're going to say this dot acceleration. And essentially what acceleration is how much the speed changes over time. So right now, our particles, so if we have one particle, like a box here, here's our box. See if I can draw a box. Okay, so when our particle starts, it's going to be assigned a random x speed. So that means every frame it's going to move some value this way on x, and it's going to keep going x, x, x every frame. And then it's some other random value on y. Let's say it's a little bit bigger, so it's going to go y, y, y every frame. And then of course there's another one on z, which is, you know, going somewhere like this. And so when speed is constant, let's say this speed is like 1 and this speed is 0.5, then it just moves the same rate every frame. So you get a nice linear animation. Okay, so that's speed. What we can do to change the speed is add velocity. And so velocity is the change of speed over time. So if our velocity was something like 0.1 on y, then if our first one was 1, then the next update would be 1.1. So it would be a little bit bigger. And then the next update after that would be 1.2. So we'd be growing by acceleration over time. And that's how you get something like gravity, the effect of gravity, where rain falls, it's getting faster as it approaches the ground, or an acceleration in fire, where as the fire gets further away from the source of the flame, it starts to disappear more quickly. So acceleration is a pretty simple way to add some really nice effects to our particle system. So let's go back. So for our acceleration, we're going to do create vector. And since I'm working with the y-axis kind of being faster than the other two, so the y-axis is kind of like our direction, it's kind of like going in the y direction, I'm just going to apply some velocity on the y-axis. And I'll show a couple different examples. So we're going to say 0 for x, and for y, let's just say 0.1, and then for z, I'll say 0. So the way that we apply acceleration is really simple. In update, we say this.speed.add this.acceleration. Okay, so we're adding the speed to the position. So the position is where the object is in space. So as we add the speed, that position moves. When we add acceleration to the speed, now the speed is updating. And so what we'll see is the y is going to go a lot faster. And actually, let's do negative so it goes in the same direction first. So now you can see the particles are moving up, but they're also increasing how fast they're moving up. So 0.1 is actually a lot. Let's do 0.05. So you can see the particles kind of start out slow and then they get much faster. And so now we can actually reduce y. We can even make it like 0 to begin with, but then the acceleration will quickly catch up with the other forces. So now our particles are moving much faster on y than they are on x and z. And so we can see that our system goes much higher than it would before. So we can reduce this even more. We can say like 0.1. And so now we'll get a little bit of volume at the bottom here, and then they start to go up really fast. So that's a pretty good effect. And then if we made the initial, another way to do this, so you could stop here, this is good, but another way to do this is to give a very high initial speed, but then do a velocity in the opposite direction. So let's say our initial speed was -2, so we're going to go up really fast. But then we start applying velocity, acceleration in the other direction. What we're going to get is a sort of fountain effect, or gravity effect, where our particles start to kind of loop down, because they're going a little bit on x, they're going a little bit on z, they're going really fast to start on y, but then the acceleration is slowly catching up with them, so it's going to start to go down. So let's say we increased our acceleration to like 2. Now we're going to see even more of a little fountain effect. So depending on what effect you're going for, those values can really kind of make cool different options with our physics. So I'll leave that as it is for now. I'm actually going to increase the x and z again, just to get this a little bit further away from the center, just so we can kind of see our nice geometries. Okay, so that's kind of cool. We have this little fountain effect. So I'll just stick with that. You guys can kind of play with these to get a particle system that you like. Okay, so now let's add a few more effects, but let's put in our lighting and our materials first. So we can add some other animations to our particle system, and then the last thing I'll do is add in my cat composition. So I'm going to take out the stroke and fill here, go back to just our regular box. Okay, so with our box, it doesn't really, it kind of looks interesting, but it's very square, so it's not really the effect we want. But there's a lot of ways that we can kind of play with that. So let's start by, I'm going to leave the box for now, just because it's a good example of how our geometry looks. But I'm going to add some changing color and some changing rotation as well. So let's start with the color, because we can get some really cool effects with the color. So I'm just gonna start a basic color, and I'm gonna do something a little different. My color, I'm actually gonna use a vector, and that will allow me to also change the color over time. And so I can still, a color usually has R, G, and B values, whereas a vector has X, Y, and Z, but we can store color data in a vector. We just have to remember that it's color data when we create the color. So our color will be this dot color, and we'll just make a vector. So we'll say create vector, and I'm just gonna start with like a little blue color. So I'm gonna say 0 red, 0 green, and a random amount of blue, like maybe 100. Actually, I'll do a little bit of red and green, say like random, like 50 red and random 50 green, and then maybe random like 200 on blue. So we'll get some like blue color to start, but they'll be random. So that's our color. So to start, let's draw the color. So we need to use a material here. So there's a couple different materials we can use here. So I'm gonna go over the basic material we had last time, the ambient material first. So this is gonna reflect light, but it's not gonna be shiny. So if we have an ambient material, we can add in our color. So we can say this dot color dot X. So remember, X in this case is gonna be the red value. So we're just converting XYZ to RGB. So this dot color dot X, this dot color dot Y, and this dot color dot Z. So now we'll see different colors in our boxes. So it's a little brighter than I want it to be at the beginning and a little more red than I want. So let's actually set a floor for the blue at 50. Okay, so now everything's blue. And let's lower this down to 100. And I'm gonna lower these guys down to like 20. I want them to be kind of dark to start. Okay, so there's our blue colors. And so because they're ambient, they're reflecting the light, but they're just kind of like dull colors. So the other type of material we could do is a specular material. So if I do specular material and just use the same color, and you can also combine these with different shapes, but you can only apply one per shape. So our specular material and maybe some shininess. We would need actually a point light for this to work. Let's grab our point light from our previous example. So I'm gonna go to 3D Cat, go to Sketch, and here's our point light. I'm just gonna copy that and throw that in our new sketch. So here's sketch.js. So after the directional light, I'll put in a point light just so we can see some highlights. Okay, so now you can see with the specular material some kind of shiny highlights. So we can use that point light that's interactive with our mouse to kind of see a little bit more of those geometries. Just like we're animating our speed, we can animate our color. So let's go back to our particle. So here's our color. And we can update the color just like we're updating our speed. So I'm gonna make a speed for the color. I'm gonna say this dot color speed, and that's another vector, so create vector. And it's kind of just like the speed here. If I want something to go fast, I give it a number, a high number. If I want it to go slow, I give it a low number. If I want some variation, I use random. So if I do 0, 0, 0, let's make the red grow fast. So I'll say red is like 5. And then in my update function, I'll just say this dot color dot add this dot color speed. So see, now my particles are gonna get more and more red over time. That's actually maybe a little bit too fast. So let's just bring that down to like 1. Okay, so now you can kind of see. That's kind of nice. Another thing we can do to the color is add an alpha, okay, so to make it a little transparent. So alpha is like 0 to 255. So if I do something like 200, they'll be a little bit see-through. So we'll start to see through some of our shapes. That's kind of fun. If I bring it down to like 100, then it'll be like A lot less color because we're seeing mostly through the shapes. But you do still see those shiny highlights. Okay, so let's bring the alpha back up to like 200. Okay, that's kind of nice. And then let's add our speed. So 1 for red, let's do 1 for green. Let's actually do 2 for red, 1 for green, and 1 for blue. So we'll eventually get to white. So we'll get kind of pink, and then as we get down farther, we go to white. Okay, so that's kind of fun. So of course we could add acceleration to our color, but I'll let you guys do that if you're interested in trying that out. For now, I'm pretty happy with this. I'm gonna make some changes as well from going from here. So one thing that is kind of boring about this is that all of our rectangles are facing the same way. So we can create a rotation to start, and then we can even animate that rotation. Oh, I forgot to mention you can pan by using the right mouse. So drag with the left is rotate, left mouse is pan. I forgot about that. Okay, so let's add some rotation. So I'm just gonna start with a basic rotation. So just a default rotation. So again, we have 3 axes, X, Y, Z, so we can use a vector. So after our acceleration, I'll say this dot rotation, and this is where it's gonna start. So to make a little variation, I'm going to add some randomness here. So if I just do 0, 0, 0 on the rotation, and then we apply the rotation. So with rotate, I can't actually do X, Y, Z. I have to do them as separate functions, so it's a little annoying, but I can just do rotate X, this dot rotation dot X, and I'll include this in a template so you guys can just copy this. You don't have to write all this code out. This dot rotation dot Y, and rotate Z, this dot rotation dot Z. Okay, so now if we have 0, 0, 0 for the rotation, they're all gonna stay the same. Okay, but if we do some randomness, then we'll see random rotation. So I'll do a random rotation on each one. I'll just say random to pi, so it can be up to a half rotation. So I'll do random pi on every axis. And so now we'll see some different rotations. Okay, so now our boxes are kind of all over the place. So that's kind of cool. So we get a little variation there. We can make that even more interesting by, let's see if we can get under this guy. Okay, so we can make that even more interesting by animating our rotation. So just like the speed of our color and the speed of our position, we can make a speed for the rotation. So after our rotation, basically the same thing, this dot rotation speed, create vector. Okay, so these, even though we're using pi for our rotation values to start, we don't want to like increase by a ton here. So I'm just going to use really small values here again. So I'm going to say random 0.01, something really small. I'm just going to start with that on all of them just to try. Since it's a box, it doesn't really matter that much which way it's rotating, but you could play with this to get different effects. So again, we have to think about how these things are similar or different. Like our position is the X, Y, Z, and that can be, you know, any number in space. The rotation is based on pi because it's a rotation around an axis. Our colors are 0 to 255, but then our speeds for all of those are very small numbers because they're being accumulated very quickly as our program runs. Okay, so we have our rotation speed. To add those, we just say this dot rotation dot add this dot rotation speed. Whoops. Okay, so now you can see the boxes rotating as they move, which really creates a much more natural feel for our particle system. Okay, one more thing that's might be useful. So we have the specular material, the ambient material. There's a third material that we haven't done yet, which is the emissive material. And this means that the material is actually emitting color rather than reflecting color. So this one is not going to be as dependent on lighting. And so it might be kind of a cool option. So again, you can use whatever material you think looks best, but the emissive material might look better for a particle system because it actually adds the color together rather than reacting to the lighting. So you can see with this, the boxes are no longer like reflecting light at all. So that might not be the best option for your design, but it could be kind of fun if you're trying to make like smoke or fire or something like that.